Alright, hello geometry. So today we're looking at the law of sines, and you may have noticed if you're looking at the numbers, this is 8.6a. So I split this one up into 8.6a and 8.6b because this section is both the law of sines and the law of cosines, and neither of them is particularly awful, but they both get kind of long, so I figured I'd split that up into two videos and two assignments. So we're looking at the law of sines first. And the law of sines is a thing that you're going to want to jot down because we're going to be using it for like all of these triangles. So go ahead and take a moment to jot this down. So the sine of A over A equals the sine of B over B equals the sine of C over C. Your capital letters are your angles, your lowercase letters are your sides. And you want to make sure that the side with the same letter is across from the angle with the same letter. So big A is across from little a, big B is across from little b. Big C is across from little c. So as long as we have our triangle set up like that, then we can use our law of sines, which you may notice is going to just end up being a bunch of ratios that we're going to end up butterflying. So once we've got our stuff filled in, it's really the same stuff that we've been doing with ratios and similar fractions and all those things. So I'm going to assume at this point you've either written this down or taken a screenshot or something, and we can move on. So what we're going to do with this is we're going to finally get into solving things that aren't right triangles. So nice thing about the law of sines is this works for any triangle. So pretty much everything we've been doing so far with the Pythagorean theorem and with sines, cosines, and tangents, that stuff has only worked with right triangles. Now we're getting into the stuff where we can use this for any triangle, which is nice, because you may notice this is not a right triangle. So before I go ahead and plug anything in, I'm going to go ahead and label this. And since I've got these two angles here, I'm going to call this angle A. I'm going to call this angle B. I'm going to call this one angle C. Now, again, you can go in any order with that as long as I put big A across from little a. And I put big B across from little b. And I put big C across from little c. So the thing we're actually looking for here is little a. And we have big A, big B, and little b. So I'm just going to go ahead and fill these into the first part of the law of sines. So that's sine of A over A equals the sine of B, not sine, over B. So we're going to go ahead and fill those into that. That's a little a, kind of like a fish there. Now, depending on what you called these angles and what you called those sides, you might end up using this, you might end up using C. You're going to end up with the same thing, but your fractions might look a little different depending on which thing you called these angles. So we have the sine of big A, so sine of big A is 37, over little a, which is x, so that's the thing we're looking for, equals the sine of big B is 120 over little b is 15. Now, when you're setting these up, you do want to make sure that that sign needs to be there. So we can't just go like 37 over x equals 120 over 15. That needs to be the sine of 37 and the sine of 120. Now we're going to turn them into numbers, because the sine of something is just a number. And again, make sure your calculator is in degrees. So we want the sine of 37. Technically, this would also work if you're in radians, as long as you don't, like, switch halfway through. So if we've got the sine of 37 is 0.602-ish over x equals the sine of 120 equals 0.866 over 15. And the nice thing is, once we've got that set up, we're just multiplying. So once we're here, we're just finding the sine of these things. These are just numbers, and we're just butterflying this. So now we've got 0.866 times x equals whatever 15 times 0.602 is. 15 times 0.602 is 9.03. And then we can just divide by that 0.866. Those are good. And we've got 0.866, 10.4-ish. And again, if if we're looking back at our triangle, we're in the right general ballpark. So if we've got a bigger side over here, we know we want it to be across from a bigger angle. So if this is 120 and that's 37, okay, 15 needs to be bigger than whatever that side is 10.4. Okay, and this one we were just looking for a side. We're going to eventually get into ones where we're trying to find like all the sides of your triangle. Those are going to be a little longer, but if we're just looking for this side, that's the only thing we need there. Okay, let's try another one of those. Now, let's say we got this one. Oh, that got smudged a little bit. Alright, so let's say we got this one. We got 80 degrees, we got 30 degrees, and we got an 18 between them. Now, you may notice if I start calling this A, and B, and C, and little a, and little b, and little c, we don't actually have a whole fraction if we start making our law of sines. Because in order for the law of sines to work, we either need the sine of A and A, we need the sine of B and B, or we need the sine of C and C. So we need one complete pair. We don't have that yet because the side we have is this one, that's across from this angle. But, nice thing is, if you happen to remember that triangle angles add up to, hopefully it's at 180 degrees, so we got 180 degrees minus that 80 minus that 30 gives us 70 for this angle, even though it's not there originally. So occasionally you're going to have to find one of your other angles first in order to actually set up the law of sines. Because if we want to start setting up the law of sines, we got this sine of A, which is 70, over little a, which is 18, equals the sine of B, which is 80. Over little b, which is the thing that we're looking for. Now, we could also use this to find c, because we already have c. We could use it to find this, but this is the thing we're looking for, so I'm going to use this. Okay, now, same sort of thing. So sine of 70 is just a number, and sine of 70 is about 0.9396. To 7. And you may notice I'm rounding these, so 3 or 4 decimal places is fine. Technically, the more decimal places you put on there, the more accurate your answer is going to be. 3 or 4 is close enough. And we got 18. And we got the sine of 80, which is 0.9848. Over x. Okay, and now we're just butterflying. So now we're just going to take that, and these. And we've got 0.9397x equals whatever 18 times 0.9848 is. 17.726. And then we're dividing by that 0.9397. Gives you about 18.86. Which, if we're looking back up at our triangle, that looks like a reasonable thing to get, because 80 was across from this, so that's our biggest angle. It's going to be across from our longest side. 18.8 is bigger than 18. 70 is pretty close to 80, so okay, those sides should be pretty close together. We're in the right ballpark. So once you got your answer, just go in and double check and make sure that that answer makes sense with the triangle that you got. Okay, now, the last thing you're going to see with these, and the reason these kind of get a bit long, is you're going to see the phrase, solve the triangle. And solve the triangle is just a fancy way of saying, find all of your things. So we want all the sides and all of the angles, and that's an arrow sign, not a little right angle. I can see that where that would look like a little right angle there. Okay, so that was an arrow pointing up. Okay, so if we've already got angle A and angle B, we're going to need angle C. So I'm just going to list all the things we're looking for over here. And we're going to need, we've already got little a, little b is across from big B, so we're looking for little b. And we're also looking for little c. So we're looking for 3 things here, and in general, the easiest thing to find quickly is probably going to be your third angle, because triangle angles add up to 180, so 180 minus 62 minus 75 is 62 minus 75 gives you 43. So that's one of our things right away. So there's our third angle. And now we can use the law of sines to find your other two sides. So I'm going to say the sine of 75 over the side we've got there, which is 15. So sine of A over A equals the sine of B, which is 62, over little b, which is the thing we're looking for. Okay. And then we're just going to go ahead and find the sine of 75. Sine of 75 is 0.966 over 15 equals the sine of 62, which is 0.883 over b. Okay. And then we're butterflying that. So we got 0.966 times b equals whatever 15 times 0.883 is, which is 13.245. And then we're dividing by that 0.966. There's a go. Which gives about 13.7. Okay, and that gives us B. Cool. Now we're going to do the same thing, but with C. So instead of going through and rewriting all of this, I'm just going to replace the things that we now need to change. So instead of looking for B, we're looking for C. This whole fraction can stay, but this was the sine of B. Now we want the sine of C, so we're going to call that the sine of C is 43. That's going to change this. That's going to change that. Which is going to change this. And, okay. So instead of B, we now have C. And we've got the sine of 43 instead of the sine of whatever the other thing was, 0.682. So this 0.966, that can stay. That's going to be the same. But now we're taking it times C instead of times B. And now we're taking 15 times your 0.682. Times 15 gives you about 10.23. And now that's the thing we're dividing by 0.966, which gives about 10.59. I'm going to call that 10.6. And again, if we're looking back at our triangle, okay, those look like reasonable things to get, because A is our biggest angle, that's across from our longest side. 15 is longer than both of these. B is our next biggest angle because 62 is bigger than 43. 13.7 is bigger than 10.6. Okay, we're in the right ballpark. These look like reasonable answers to get. This is the reason we're doing half of this today. Alright, one more of these. So we've got angle B, we've got angle C, and we've got side A. So we're looking for angle A. I should leave myself a little bit more room there. Oh dear, that's much. So we're looking for angle A, and we're looking for little b, and we're looking for little c. And again, in general, the easiest thing to find first is going to be your third angle. So 180 minus our 108 and our 29 gives you 43, so that's your third angle. So in general, your third angle is going to be your easiest thing to find first, because now we don't have to worry about do we have the angle across that side, because we have it for all of them. Alright, so now we got the sine of A. So the sine of 43 over little a, which is 17.5, equals the sine of And let's go ahead and find b first, so 108 over little b. Now, you can do these in any order. I'm just going straight down in the order I listed them in, but you could find c first if you wanted to. All you'd have to do is put c there, and instead of 108, we'd have 29. You'll end up with the same thing. Okay, so now we got the sine of 43, which gives about 0.682 over 17.5 equals the sine of 108, which is 0.951 over little b. And then we're butterflying that, so we got 0.682 times b equals whatever 17.5 times 0.951 is. Is about 16.64. And then we're dividing by that. I should make that decimal point bigger. There we go. We're dividing by 0.682. Which gives you about 24.4. 24.4. Which, if we're looking back at our triangle, okay, that makes sense. B is your biggest angle. 24.4 is going to end up being our longest side. It's bigger than 17.5 we've already got, so that's looking pretty good. Okay, I'm going to leave myself some more space over here. Hopefully this will fit. I've been trying not to go into extra whiteboards. Okay, so now we're looking for C. So we've got the sine of, and technically you can use either the sine of A over A or the sine of B over B to find this, but since we rounded to find B, I'm just going to go ahead and use the sine of 43 and the 17.5 that we started off with. Technically, that's the one you should use. If you use this one, because we've already got B and then the sine of 108, that's okay. Technically, we rounded this, so technically that would be rounded, but we're rounding things anyway. You'll get close enough. Okay, so now we got the sine of 43 over 17.5 equals the sine of C, which is 29, over little c, which is now the thing that we're looking for. And then we're just finding the sine of 43, which is going to be that 0.682 that we had over there. So this fraction, it doesn't change. And we got the sine of 29, which gives you about 0.485. Let's make over c. And then we're butterflying that. So we got 0.682 times c equals whatever 17.5 times 0.485 is. Gives you about 8.48. Typically that'll round up to 8.49. And we're dividing by that 0.682. 0.682. Dividing by that. So you got C is about, oh, here goes my cat. Okay. Mirage, you're gonna have to move. I'm almost done with this one. Almost done. Almost done, kitty. Whoops. Okay. Alright, and we got 8.49 divided by 0.682 is about 12.45. Yeah, 0.44, yeah, 0.45. So we got 12.45. And again, if we're looking back at that, that makes sense as an answer, even though this is definitely not drawn to scale, because our 29 is our smallest angle, that should be across from our shortest side, so C is our shortest side, and we're good to go. Okay. Yeah, that's why we're just doing this half of this section today. Alright, so these get a little long, but mostly it's the butterfly stuff that we've been doing, so hopefully this part isn't going to be too tricky. The law of cosines gets a little bit trickier, which is why I'm saving that for the next video. So go ahead and check out the homework in the description below, and I'll see you in the next video.